Hello and welcome to my tutorial on building multi-platform UI applications for Windows, macOS and Linux using wxWidgets and CMake. So what's the motivation for this? We would like to use the same code base, the same C++ code and the same build system scripts to build a native UI application in Linux, Windows and macOS. We will be using wxWidgets library, which is a multi-platform UI library built exactly for this purpose, right? And it's a great library because it's free, it's open source, and unlike, for example, Qt, which is another multi-platform UI library for those operating systems, wxWidgets, unlike Qt, is free also for commercial purposes, so you don't have to pay for any license, anything like that. You just download the library, compile it, link it with your files, and it's good to go, right? So that's a great thing about wxWidgets. We'll also learn the CMake super build pattern as a modern way of managing and downloading dependencies for C++ projects. CMake is a build system generator. It's a multi-platform build system generator. It can generate make files for Windows, for Linux, for macOS, and then it can build those files generating the native application. For example, for Linux it generates the ELF file, for Windows it generates the exe file, for macOS it generates the macOS bundle. So it's another multi-platform tool that allows use one code base, one build system code base to build for all those platforms. And super build pattern is like a new addition to CMake, which allows for downloading dependencies on the fly. So you don't have to have the library installed in your system. You can search for the library. If it's not found, you can download it from repository, build it on the fly as a part of building process for the whole project in CMake. So this is a great new addition to CMake. We'll be exploring how it works and how it can be used. So how exactly we'll achieve this? We'll have to organize the main project and its dependencies using CMake's external project module. This is the super build pattern that I mentioned before, and we'll be diving deeper into it when I show the code for that. And for dependencies, in this case wxWidgets, we'll try finding the package first. So if the wxWidgets library is already installed in the system, there is a CMake module that is able to find this library. And in this case, we won't be downloading anything, so because the library is already in the system, so we'll be just using and linking our project against the library that is already installed. But if the package is not found, we'll download it from GitHub, build it, and install it in the local build directory. Okay, so let's dive into the code. This code is available on GitHub. You can download it for free, and you can follow me with this code to follow the tutorial here. Okay, let's explore the directory structure here. So we have basically two directories, source directory and third-party directory. In the source directory, we have the main C++ file. This is nothing but the wxWidgets Hello World program downloaded from their site. So very basic window with exit help file, like some Hello World text, etc. Right? Very, very simple stuff. So this is the source directory. You also have a CMake list for the source directory. We'll get to that later. In the third party, we have only build scripts that download or look for the wxWidgets libraries in the system. And we also have a main CMake lists file, which is the starting point for the CMake build system. When you run the CMake command, it looks for a CMake list txt in the main folder. So that's it. That's where everything starts. So let's explore this file, see what happens here. We set required version for CMake, so we have all the features we need. We make sure that we use the correct version. We set the project name, we set the language for C to C++, we set C++ standards, etc. We set some directories. This one, the EP base, will be a directory where we'll be downloading external projects, where we'll be placing their sources, their build artifacts. This one, stage install prefix, will be a directory where we'll be installing the downloaded libraries. So here we download sources, here we place build artifacts, and then we install the binaries to this directory. And from that directory, they'll be used by the main program. So next we add this third-party directory. So we make sure the CMake system reads this CMake list txt files from this directory. And we add an external project. So in this configuration, this directory is an external project, and this one is an external project. So we have two external projects. Here we add one, we add this one, and we make sure this one, so the main file, main program, main window, depends on this one. So we make sure that the wxWidgets is either downloaded or found in the system before we are starting to build the main project. You can see the source dir here is exactly this one directory. So this way we make sure that the external project with this name points to this source directory. Here we set some CMake flags. We'll skip this for this tutorial. And here we set also some important variables for wxWidgets. We'll get back to those a little bit later. So basically this build script sets up everything like the configuration we wanna build, right? So we set up the external project from this directory. We make sure this external project depends on this directory, right? Third party. So this is basically what this does. And that's it. So let's maybe go to our first external project. Let's go to this directory and see exactly what is being built for this external project. Here's the build script for the main project, for the main external project, the one that contains our window. And let's just go line by line and see what's going on here. So at the beginning, we set some basic variables. We set the project name. We'll talk about this a bit later because this is a little hack for the CMake scripts. We need to place it so that it works correctly on Unix systems. Here we set the linking type to static. So the wxWidgets library will be linked statically. And again, we are looking for the wxWidgets library using the CMake scripts. So notice that this file, obviously, the main C++, requires wxWidgets. But here, when looking for this package, we don't really specify if we want to look in the system or if we want to look in the build directory after we download the wxWidgets from the GitHub repository. This information is set here, so we'll get to that later. But just notice for now that the build script for the main project doesn't really care where we want to look for the wxWidgets. It just needs the wxWidgets. This is required, and this is needed to compile this main C++ file. So we set the sources. This is just one file, one main C++ file. We set the include path, so this is forwarded to the compiler. Compiler knows where to look for the wxWidgets include directories, and this variable is set by this find package script. Here we add the executable, and this is like really nice feature. We just have one if we are compiling on macOS system, we are creating macOS bundle. If not, we are creating we are using the winmain function for Windows, because Windows UI applications look for winmain function in the code, not for the main function like normal C++ standard. But this this tag is ignored for Linux, so this line works correctly for Linux and for Windows. So we just want if we specify the build for macOS, for Linux, and for Windows, which is pretty nice. And then we make sure we point to the correct path for libraries for the linker, so the linker knows where to look for the wxWidgets libraries. This also is set by the find package script. Here is the build script for our wxWidgets external project, right? So what we are doing here is we are looking for the wxWidgets in the system. This uses the CMake script, the built-in CMake function to find wxWidgets in the system. And if we do find it, this is the variable set by this script. If we do find it, then really we don't need to do much else. This is just the end of the script. We just set the dummy dependency because remember, the main project, this main C++, depends on something called wxWidgets external. So in case we find wxWidgets in the system, we need to set a dummy library so that dependency is satisfied, right? But other than that, we don't really need to do anything else, because if we find wxWidgets here, it means that we also gonna find it here when compiling the main project, right? So here wxWidgets are not required. We check the found variable, and if it's not found, we do something else. But if it's found, it means that here it will also be found. So we can safely require here the library, and we are sure that this will be the library that is found in the system. So everything goes smoothly from here for the main project. We compile the sources, we add the includes, we add the libraries because we found it. We found the wxWidgets in the system, because here that's the answer we got from the script. But if we don't find the wxWidgets in the system, then we set up again another external project. We name it wxWidgets external again because this is the dependency required by the main project, right? This requires wxWidgets external. So we declare what wxWidgets external is in this case. If it's not found in the system, then wxWidgets external is an external project with this repository, with this branch to download, etc. Right? And we set those variables that I mentioned before. And let's maybe see why we do it and how does it work. So we set the external project, and since this external project is required by the main project, it will be built before the main project is built. So CMake will download the wxWidget, we'll configure it, build it, and install it in the stage directory. So before we even start to parse this file, we know that this dependency must be satisfied, so CMake will install this external project. So we can safely say set the variables that point to the place where the find package will be looking for the wxWidgets. Because right, remember, in the main build script, we have this find package wxWidgets required. And this is nothing but a built-in script in CMake. This is actually this script. This is like in the user local, etc. Right? So this is from the CMake installation. And this script looks for wxWidgets. By default, it looks in the default directories for installation, user local or whatever it is in Windows. But you can override it and set the directory where the script should look for the wxWidgets, right? So if in this external project, like in this CMake script, just remember this script is included here at subdirectory third party at subdirectory wxWidgets. So this script looks for the wxWidgets in the system. If it's not found, then it sets up the external project, and it sets up the root directory for wxWidgets to the directory where this external project will install downloaded binaries, right? Downloaded library. So again, when we are back in the main project here, and when we look for the wxWidgets, if we set the wxWidgets root directory, this script will look for the library in this directory. So we download the wxWidgets here, and we also set the directory to here, right? So after this all is done, and we start compiling the main project, this variable is set to the place where we installed the downloaded library. Then here, this line find package forwards this this variable with the directory to the script. So in this case, where wxWidgets is not found in the system and we have to download it, second invocation to find package will look for wxWidgets not in the system, but it will look in the staging directory where we built and installed the downloaded wxWidgets. So this is the trick that allows for the main script just to have find package, just find new wxWidgets, and I don't care where it is, and we control really where this line looks for the wxWidgets library. We control it from here. So if wxWidgets is in the system, just look in the default place. If it's not in the system, then look in the stage install prefix, so in the directory where we installed the downloaded library. Before we move on to recap what we learned here, we need to address one little thing, and this is this little hack for find wxWidgets script. So what is it, and why is it here, right? What is it doing? When we take a look at the find wxWidgets script, which is the one we are using here when looking for wxWidgets, and also here again when looking for wxWidgets, this is a built-in script in CMake. We can see that they claim that if you set wxWidgets root directory, we'll be looking for wxWidgets in this directory. So we do exactly that. In case when wxWidgets is not found in the system, we download it from external repository, and we set wxWidgets root directory to the place where we installed the downloaded library. So this is good. But if we dig a little bit deeper in the script, the CMake script, you can see that we are looking for this. The authors of the script are looking for this variable, but only for Windows. We scroll down for Unix, basically Linux or MacOS. We can see that they don't actually look for that variable. They basically ignore it, right? In this else branch, they don't look anywhere for that. What they do, they are trying to find the wx-config executable, and if it's found, then they set wxWidgets found to true. So if they don't find it, they don't care about this root directory, and they pretend that wxWidgets is not found even though we set the variable as we are supposed to do, right, as the documentation say. So a way to work around this is to set this environment variable. So we set the path to wx-config file. So when in Unix the script, the find wxWidgets script gets to this place, it uses our variable and is able to find the installation of wxWidgets that we built and installed after downloading it from the repository. So let's see how it works. In our CMake lists in wxWidgets external project, we set the root dir, this works for Windows, and also we set another variable which points to the wx-config program in the build directory. And then here in the main project, because this is CMake variable and the find wxWidgets script looks for environment variable, not the CMake variable, we need to set the env variable to point to the CMake variable. I hope this makes sense. It's not very important. This is just a hack because basically because the CMake script that is bundled with CMake doesn't work as it's supposed to work, as documented. So this is just a little workaround, but I wanted to show you why is it here and what does it do. All right, let's recap what we learned. Let's go through all the files, all the build scripts, and see what happens in the case where the wxWidgets is found in the system and the case where we have to download it from the GitHub. Okay, so we start from the CMake lists in the root directory. Here we set some variables and we add subdirectory third party. We go here. This is actually just adding another directory. So this is the script we're adding. We are looking for wxWidgets package in the system using built-in find wxWidgets script. Built-in meaning this is from CMake. If we do find wxWidgets in the system, then we basically add the dummy dependency and that's it. We go back to the root script. We add external project, the main file, the main source, the main project will be our external project, and it depends on the dummy dependency we set here when looking for the wxWidgets. So we are ready to build this main project because we set build always to true, so it's always being built when this root CMake list is run. So in order to build this main project, we need to execute, the CMake will execute the CMake list here from the main project. Here we set some variables and we again look for the wxWidgets package. This again runs this script and it finds the wxWidgets because, well, we found it here, so we're gonna find it again here. We set up our sources, we add our include directories, we set up our build for macOS, for Windows, for Linux, and we add our libraries, and that's it. The result will be this main application built with this build script. So in case the wxWidgets is not in the system, let's go back to the main script. We add the subdirectory third party, add wxWidgets directory. We try to find the package in the system, it's not found, so this is not true. We go with this else branch. We add another external project named wxWidgets external, which is required by the main project. So we set up this way that we download the wxWidgets from the repository, we build it, we install it in our stage install prefix in the build directory, and we set wxWidgets root directory to this stage install prefix directory. This way, when this main project is being built, this one. And when we look for the wxWidgets package, since we set this wxWidgets root directory, or this one, if it's Unix hack, right? Since we set this variable to our build directory, this line, this built-in script, will be looking in our build directory where we have downloaded, built, and installed the wxWidgets from GitHub. And again, we add sources, we add includes, we build the file when we end up with an executable with wxWidgets links linked to our program, right? So yeah, so this is the way to do it. No matter if the wxWidgets is in the system, is installed in the system, or it's not. If it's not installed, we'll download it, install it locally in this directory tree in the build folder, and the main project will use the correct wxWidgets package always, whether from the system or the one that we install it and build using this super build pattern. Let's see how it works on Windows. So for Windows, you'll need to install the build tools. In this case, let's just install Visual Studio, the free community release, and we'll have to install Git. All else will be downloaded by the script, so we don't need to install any other libraries. Okay, so let's do it. When installing Visual Studio, you need to remember to check this box, this development with C++. We'll have CMake, we'll have the compilers, everything we need excuse me, for the installation. Visual Studio installed without any problems. Git also is installed, so we are ready to download the code from GitHub and run it. We need to run the correct command prompt with all the paths set to the compilers, etc. And clone the code from GitHub. Let's now run CMake to configure our project. As you can see, CMake automatically found a correct compiler for the platform, Microsoft Visual Studio compiler. And we have our config files written in the build directory. Let's now build a project. It will take some time because we need to download the wxWidgets library, we need to compile it and install it, so be prepared to wait a bit for that, but it's just the first step. When you compile your project next time, the library will be installed in build directory, so you won't go through this step again. The build is ready, so let's run the program. So we have our first UI application, the Hello World application. You can see it looks and feels like a Windows application. So it's really native app. Menu is working, some dialogues, very basic stuff, but the point was to use CMake to automatically download wxWidgets and compile the application using just the built-in libraries, built-in build tools. Okay, so that's it for Windows. Let's do the same on macOS. Again, the fresh installation of the system. So we'll need to download the build tools. The easiest way to do it is by using Homebrew. It's a free package manager for macOS. Let's copy this script. run it. Let's now install CMake using Homebrew. And let's download the code. Configure step. And build step. The build finished. Let's see what are the results, what are the build artifacts here. So we have our application in the form of a macOS bundle. Let's run it. And again, we have a native application with proper direct theme. We have many on top like usually on macOS. And we have all the functions we had in Windows. So that's how it works on macOS. Last but not least, let's do the same on Linux. So we'll need a build system and UI libraries for Linux, in this case GTK. So let's just install this package and it should install the build system, the compilator and everything as a dependencies. Let's now install CMake. And download the source code. Maybe let's install Git as well. CMake configure step. And build step. Alright, the build finished. Let's see what we got here. We have the main file, which is a compiled elf executable. Let's run it. And here we are with our example program. Again, everything looks and feels like a Linux application, like a GTK application, so it's great. Alright, let's try something else. Let's delete the build artifacts. And let's install the wxWidgets from the Ubuntu repository. Let's now configure our program. As you can see, the CMake script found pre-installed wxWidgets libraries, so it won't download anything from GitHub. Let's build it. As you can see, the build process was much faster because we weren't building wxWidgets lib. And let's run main. So everything works, and this time we linked against the library that was pre-installed in the system. As you saw, the CMake script was able to detect that the wxWidgets was pre-installed. So that's it, I think. That's it for this tutorial. Thank you for watching. Like, subscribe, and we will see you in the next one.